All right, so chapter 9 is here, and let us look at how to create confidence intervals. Um, in the book, I'm going to look at the first one. When we talk about confidence intervals, we're trying to guess what our population proportion is. So the way that we do that, we want to find our population proportion, right? So a good guess for it. And the way that we do that is we take our p hat, which is from a sample that we've taken, and we add and subtract this margin of error. This whole thing just represents a margin of error. So we could do these calculations, or we could have StatCrunch do them for us. So let's look at a problem. I'm going to have a 90% confidence interval. I know that number of successes is 160 and n is 200. Well, they don't tell us exactly what our p hat is. Again, p hat is x divided by n. So if I want to do this on StatCrunch, it's very simple on StatCrunch. We go to Stat, Proportion Stats. In Chapter 9, we're just dealing with one samples. And we have a summary of data. So we know that there are 160 successes out of 200. So that's actually what we type in. We don't actually have to find the p-hat. StatCrunch will show us the p-hat in a second. And then we do a confidence interval. Ours was 90%. And we compute. So it tells us our sample p-hat, or proportion, that would be 160 divided by 200 is that 0.8. But here is my lower limit and upper limit. So I am 90% confident that the population proportion is between roughly 75% and 85%. That's what we are saying. So again, they gave us successes, total number, and they told us what percentage that we wanted. So that's all we need. Make sure we always use the standard method. There's different methods for confidence intervals. Just use the standard one. So again, that was under stat, proportion stat, one sample. If it was with data, that would be like I have yes, 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 no, no, yes, yes, yes. It would count up all our yeses versus our totals. So ours was just with the summary. In section 2, when we're estimating our population mean, I think these are on 410. Similar formula, right? We have our sample mean minus some margin of error, and we have our sample mean plus some margin of error. Now this one is involving the t-distribution. The t-distribution is very similar to a z-distribution. It's just dealt with smaller samples, so make sure you read about the t-distribution. So now we can look at a question from section 2. And we'll see how StatCrunch wants us to input it. Let's go to find one. Here we go. Simple random sample size n is drawn. The sample mean is x bar is found to be 17.5, and the sample standard deviation s is found to be that. Construct a 95% confidence interval about the mean if the sample size is 35. So to do this, we are going to go to StatCrunch. Stat. Now this would be a t-stat problem because we would be using the t-distribution. We only use z-stat if we know the population standard deviation, which is almost never. If we're trying to figure something out about the population mean, how would we not, if we're trying to figure about the mean, how would we know the population standard deviation? So that's why we're using t-stats. Again, this section we're just dealing with one sample, and let's say we have a summary of the data. So they told us the sample mean is 17.5, the sample standard deviation is 4.5, and then the sample size is 35. Once we input our information, I think our confidence interval was 95%, and I compute my lower limit and upper limit. So I'm saying that I am 95% confident that my population mean is somewhere between 15.9 and 19.0. So I'm trying to make a good guess about my population mean. I was given a sample mean, but I'm trying to make a guess about my population mean. I believe it's in between, I'm 95% confident it's in between 15.9 and 19.0. Real quick with the t-distribution, just like we have a normal calculator, we also have a t-calculator. And what it's based off of, it's not based off of the mean or the standard deviation, it's just based off of degrees of freedom. What degrees of freedom is the sample size minus 1. So like on that last one, if we had 35, our degrees of freedom would be 34. And if I was trying to find a t-value, which would be here, here's where I would have, I could do less than, this would be a t-value that said 2.5% is this way. It would also be the t-value, it's symmetric just like our normal. If I said I wanted 0.025 to the right, it's also the same value except the opposite. So it has a lot of similarities to the normal curve, except it's actually a little bit spread out. This curve is symmetric, but it's not the exact same as the normal curve. So if there's questions like that, here is a t-calculator.